So we begin this topic by looking at the equation of a circle with centre the origin and radius of length r. A circle is really just a set of points on the circumference in a 2D plane that are all a fixed distance from a given point, in this case from the centre. So anywhere that we move this general point P that you can see with coordinates x, y, anywhere we place that in the circumference, the radius would be the same length, and in fact, we would have a fixed distance from the point to the origin. We can investigate this a little bit if we were to draw a vertical from the point P to the x-axis. Then you should be able to see, of course, that we create a right-angled triangle, where the horizontal distance here is just the x-coordinate, and the vertical distance is the y-coordinate. And this actually leads us to the equation of a circle with centre the origin. Because we can say by the distance formula, or really just by Pythagoras' theorem, of course, that x squared plus y squared must equal the radius squared. And that's the equation of a circle centered at the origin, radius, length, r. So quite a straightforward equation, and much of the initial work in circle is relatively straightforward. Of course, it'll become more difficult as we start to apply that to practical problems. So there's our center, the radius is just r, and this is our equation that we're going to begin with. Let's look at a couple of quick examples before you get a chance to practice. So in our first example, let's just find the equation of some circles. We'll be given the radius of the circle, and the center is the origin in each case. So we've got a radius of 5 units, 12 units, and √3 units. So we start with the first one. We know the radius, so we can use the general equation here, x squared plus y squared equals the radius squared, or in this case, 5 squared. And of course, we'll rewrite that as x squared plus y squared equals 25. So we can think there of a circle centered at the origin with a radius of 5 going through a number of points, including points such as 5, 0, or negative 5, 0, or 0, 5, or 0, negative 5. If we have a radius of 12 units, then applying the same idea, relatively straightforward, then for part B, x squared plus y squared would equal 12 squared. And again, we should simplify that to x squared plus y squared equals 144. So be careful here. The idea that we have to write the radius expanded or squared is important. Expanded is not the right word. So here we have a radius of √3, so it would be x squared plus y squared equals, and that would be √3 all squared. Of course, that's x squared plus y squared equals 3. So it's important to realize that the radius might not always be a whole number. In this case, it was a third, and we have to work with thirds in this topic, as you'll soon see. For the second example, we'll look at the question of whether a point happens to be inside, outside, or on the circumference of a given circle. So here we've got the circle with the equation x squared plus y squared equals 36, and we've got 3 points that we want to check. Are they inside, outside, or on the circumference of this particular circle? To do this, we'll just consider the points in turn. So we look first of all at point A. What we want to do is to substitute that point into the equation of the circle that we've been given and see if that actually holds true. So 2 squared plus 5 squared, if it's on the circle, should equal 36. That may or may not be the case. We'll soon find out. 4 plus 25 is supposed to equal 36 for it to be on the circle. Well, that's 29, which is less than 36. So we can clearly see now that it's not equal to 36. It's in fact less than 36. That means this point is inside the circle. We can think of that in some way as the radius, and the radius here of that particular set of points would be smaller than 36. Here, if we try point B, again substituting the point into the circle, This is what we'd be expected to do. We see this time that it does actually equal 36. So that point does substitute into the circle to give the right answer. So it would be on the circle. That point is on the circumference. Same again for point C. We assume that it's going to equal 36 if it's on the circle. But if we investigate, if we look at the x and y coordinates squared and summed, we get 41. This time it is greater than 36. So that tells me that this point is outside this particular circle. We could see that by plotting points, look at the geometry of the problem, but this is how we would solve that problem algebraically. Okay, it's now time for you to get some practice with the equation of a circle. If you are studying the TG textbook, then you want to look at page 76, exercise H9.1. There are 12 questions. I don't think you need to do all of those, but you should certainly try a good number of them. Similarly, for those with Heinemann as their textbook, page 212 and page 213. This is the first in 5 lessons on the circle, higher mathematics. Do make sure you check out the others to get a deeper understanding of this topic. Until the next time, good luck and take it easy.